As an introduction to this subject, we're going to teach you the groups and columns of the periodic table.
So this is the first column. It's alkaline metals. They have 1 valence electrons. Second column, alkaline earth metals, 2 valence electrons. All these are transition metals. They have from 2, 3, or 4 valence electrons. Then A3, A4, A5, A6, and A7. Those have, depending on their number, 3, 4, 5, 6 valence electrons. A8, they are noble gases. They don't want to move from there. A7, they're halogens. They want one more valence electron, so they're a noble gas. The dots that I covered, they are metalloids, and the upward part, they're other metals, and the downward part, they're non-metals.
In an element, there can only be 8 valence electrons maximum. Minimum, they can have 1. Every valence electron has an ionic charge. 1 electron has a charge of +1, 2 electrons +2, 3 electrons +3, and the fourth can be plus or minus 4. If you have 4 on one element has a positive and the second element has 4, it will be negative. 5 electrons have a -3 charge, 6 electrons -2, 7 electrons -1, and 8 has 0. That's neutral. These are the ionic charge names. Cation are 1, 2, 3, and 4. And anion are 4, 3, 2, 1. Remember, if you have a positive and the second element will have -4.
Okay, so this next one is the ionic compounds. So what you have here is the element, and as you can see on top, the element Sr has a 2 as a charge on the top of the number, like an exponent, and the N has -3 charge. So what you want to do is cross the two charges. Like you want to put -3 next to Sr and the -2 next to the N. So you will have the coefficients. In this next example, you have K as in potassium, +1 as an exponent, and then you have Br as in bromine with -1 as an exponent. So when it has 1 as a coefficient, it doesn't amount to anything. So the result of it is potassium bromine. So in this next example, you have calcium with an exponent of +2, and then you have chlorine with an exponent of -1. So what you're gonna do is that you're gonna pass the +2 to the fluorine, and since it's the negative in the second one, it's gonna be calcium fluoride.
Now for some more practice, we're going to do them backwards. Rubidium arsenide. Rubidium has a +1 charge because it is in group 1A, and arsenide has a -3 charge because it is in group 5A. It will end up looking like RB3 and AS1, but the one you don't put it in there. Now barium iodide. Ba, which is barium, has a +2 charge, and iodide has a -1 charge. So you're going to switch them, and the I will end up with the 2 as a coefficient. Now cesium oxide has a CS2O1 because cesium has a +1 and oxygen a -2.